Hello and welcome to Spacetime Camera. Here's a spacetime photo of me shaking my head no. A spacetime photo of me drinking a Red Bull. Here's a spacetime photo of me shaking my head yes. And a spacetime photo of me waving. Now these might look interesting, these might look crazy to you. Over the course of this video, I'm going to explain exactly what the Spacetime Camera app does, how it records spacetime photos, what a spacetime photo is, and all of the interesting quirks and side effects that result from it. Something you're probably all familiar with is flipbook animations. These are motion pictures in a sense that are designed by taking a series of images, typically width by height, and fanning them across time manually as seen here. I've gone ahead and drawn a more simplified and uniform variation of what a flipbook animation could look like. You could picture each individual rectangle in this diagram, or each square, to represent an image or a frame in the motion of the whole moving picture or movie. In this diagram, this direction will represent the time axis, whereas individual slides, which are at a single place in time, are represented by height and by width. If you were to take out or extract an individual frame that is one of these rectangular slides, you would be left with an image that is a representation of whatever was being filmed in the height axis and in the width axis at that given point in time. So all images we see today are height by width images. And a thought occurred, what if you could record, rather than just recording in height by width, what if you could record photographs across the time dimension? What would that look like? So this is the equivalent of saying, what if we were to record a video and stack it in frames like this, but instead of pulling out an individual single frame as an image, what if we were to kind of merge all of this into one larger 3D visual object and take our own slice out of it that is not height by width, but instead is something like this slice here I've sliced out in purple. That would come out. And this, for example, would be whatever the image data of this would be an image that is width by time. Here I'm going to record a width by time image using the Spacetime Camera app. What this feature is going to do is it's going to take a slice of the photo data that is on the width axis. In this case, it'll just be a horizontal line of pixel data here. And for the vertical portion of the image, it will be recording the changes in this horizontal line over time. Now I'm going to record it in low quality, low resolution, just so that I can record it quicker. But across high resolution, and I'll show a photo of that after this, you can see it. It looks very interesting. So without further ado, this is me waving my hand, a photo of me waving my hand in width time. And as you can see, there are a bunch of sine waves, it looks like. Now for good measure, here's a HD resolution photo of that same motion. This is a recording of my hand waving again. And as you can see, it's a little more jittery. Obviously, I can't move my hand as smoothly as I would like, but you can see it's much higher resolution. And the HD recordings do take a little longer to record, so I'm just showing you the final result here to save time. So the logical next question would be, what other slices of data can we get from this 3D width, height, time image structure we've built? So if we slice this way, we just get our standard photos, that is height by width. If we slice this way, like we just did, we find these interesting width by time photos. And of course, slicing this way from this 3D object would give us height by time photos, but there's actually a lot more we can do with this. We can slice in all sorts of directions to get interesting things. So this one, for example, this photo slice that we pull out of this 3D object would be one where width is constant, and the rest of the image data kind of records not only across time, but also across space, height in this case. This is a true space-time photo here. And so I'll give you an example now of what that might look like. Here would be an example of a photo that is recorded with width being the constant frame of reference across both time and height. So this will be a video of me shaking my head no, or a photo rather. I'll play it at 2x speed for you. I'm recording in a slightly higher resolution now, so it takes a little longer. As you can see, it's pretty interesting. It's clear, just looking at this photo, that this is a photo across space and time of me shaking my head no. Everything else in the background stays the same, but we are interlacing the time element very smoothly. And you can see that's a no. And here's me shaking my head yes. So perhaps not as clear what's going on if you were to just look at this photo, but still interesting nonetheless. So what you just saw was a photo where width was the constant, and we were kind of interlacing or interweaving the pixel data across both height and time at the same time. You can do the same thing with height being the constant and recording across width and time, and that looks like this. So once again, here's me shaking my head no. This time we're recording with height as the constant frame of reference across width and time, and you'll see it scans across width over time. So here you go at 2x speed. And here's what shaking yes will look like. Probably my favorite. So there's a lot of interesting things you can do with this concept of taking video data and pulling out your own slices across time to get space-time photos. There's some other things you can do, honorable mentions. For example, what if we were to take every frame of image data here and kind of compress them all inwards, if you will, into like one frame, one image that's kind of a combination of the data from all of these. That would be another way of representing visual data across time all in one place. And so that feature is built into the app as well. And I took a photo a moment ago here with, this is a photo of a blink. And so what you're seeing is a photo where both my eyes are both open and closed, and it it does make me look very gothic, of course, because the eyelashes look like eyeliner or something. But very interesting, and also a true space-time photo as well, probably a more common version or way of doing this, but that's built into the app as well. And one of the coolest features and one of the coolest things you can do with this app is imagine this 3D cube here of visual data represents a video, and so this is what a video is in a sense, and it's why I use the flipbook animation, which is a video format. These are called frames, and when you play the frames at a certain speed, frames per second, you get video. So something interesting you could do is to propose, what if instead of playing a video where we play each frame as the height and width data, what if we were to instead recut this so that all of the slices are height over time, and each frame is the same height over time, but across one width unit over, like this, and instead of playing the video back across time, we recorded a height time video and played it back across width. What would that look like? And so we have built that into the app as well. You can record space-time videos and play them back across other dimensions. Instead of playing them across time, you can play the videos across space. So I'll give you an example of that now. So what I've done here is I'm recording a space-time video of me spinning a card I have from a restaurant, and when recording in space-time video in the app, only the low resolution setting is available, and you can see it's a little slow to record. It's a low frame rate. Obviously, there's a ton of visual data that has to get processed for this, so that's why only low resolution is available in this version of the app. But you can see I record myself rotating this, and it will finish processing now, and you'll get to see the playback of what a Spacetime video looks like. Pretty fascinating. Here's a video of me shaking my head no, a Spacetime video of me shaking my head no. And you kind of see multiple copies of my head shake kind of blending into each other. So that's pretty interesting. So here's another Spacetime video I took when driving through my neighborhood. I just stuck my phone out the window and recorded this. And I find this pretty interesting. I'll go ahead and play it for you. The reason I think this is cool is because traditionally when you film yourself driving down the street, the things in the foreground move very rapidly and the things in the background move slowly. But when you change the dimension, you still get what more or less looks like a normal video. And the reason this is because I was actually driving across width faster than the video app is scanning across width, which causes this to look like a normal photo. Of course, smushed a little bit. You can see had I slowed down my car a bit, this would have looked like, had I driven at the speed at which the app scans across width, it would have looked like a non-smushed photo. But it's really interesting the way the background objects get smushed and actually move inverse, which is why you get this weird rotating effect. It almost looks like it's spinning. The background objects are not moving across width faster than the app is recording across width, and the foreground objects, of course, are moving so rapidly across width that it looks as if they're standing still. So a Spacetime video of me driving down the street simply rotated to a different dimension, in this case width, is a really interesting effect because it looks so similar and yet so different. So I thought that was pretty neat. So part of what I love about this app is it really gives you a better look of what our universe around us kind of looks like if you were in a higher dimension, and viewing it from different perspectives. So for example, if you could imagine that somehow we were able to transcend our 3D space and move across time as if it were a spatial dimension freely in any direction, we could kind of change our perspective. We as humans are stuck seeing seeing kind of like this, and getting new frames across time, whereas someone in a fourth dimension may see, especially if time is that dimension, may see objects for their full existence. For example, a basketball bouncing up and down, we'll see individual sections of that, whereas they might see more of a cylinder that kind of has a parabolic arc to it, in a sense. And that's very hard for our human brains to process. But if you were a 4D creature, I'd imagine you have a little more brain space as well, being that there's another dimension there, and maybe you can process it a little better. But yeah, there's a lot of really interesting things about being able to see, like, what would it look like if we were like God, and we could transcend time and observe the human race from higher dimensions, from time dimensions, and view across width or whatever angle we wish to look at. And a lot of interesting things happen. I'll show you another clip of something interesting that happens with motion, with objects in motion. When you change your perspective, they can look normal and inverse, and so I'll show you that here real quick. Here's a video of me moving that same restaurant marker across width at a speed faster than the camera is recording across width, and it looks like this. Let me restart here. And so I'll move at a slightly faster speed, and this is an object in motion that's moving faster than that perspective. And you can see what's interesting is the marker, it actually looks like the normal marker but mirrored. And so if you can change your perspective to look across width instead of across time, if you were a higher dimensional being, if an object is moving faster than whatever your ratio or skew of width space is, the object will actually look inverse. So maybe there's some weird physics particles we see that move in a mirrored direction from what we'd expect, and we might just assume that they're just moving strangely in our 3D world. But in reality, in a higher dimension, they might just be moving faster than the ratio of the space-time grid axis itself, which is causing the mirror effect. I don't know if that has any application, but I like to imagine it might. So if you were to ask a 3D creature like a human what someone shaking their head no looks like, they might draw something like this, for example. But if you were to ask a 4D creature, like a 4D creature across time, what a no head shake looks like, they might draw you something like this on the left, for example, if they're representing it across height. This is kind of a no action, or maybe they'll represent it across width, and you'll get a drawing that looks kind of like this. And to us, this looks a little insane, but to them it would be very clear. And there actually is more data here, I feel like, representing what a no head shake looks like. These are both photos, space-time photos of me shaking my head no. One is just recorded across width time, whereas the other is recorded across height time. And another interesting thing is, we're 3D creatures and we draw in 2D. So perhaps a 4D creature might draw in 3D. And I obviously can't show you what this might look like here, but it's neat to think that something, a wave pattern like this, could somehow merge with this kind of more Doppler-looking thing. How could those possibly merge in a higher dimension? And so I can kind of cheat and hold my phone at a 45-degree angle and start to show you kind of how we still have these effects of the wave and the Doppler kind of combined. And so it would probably look something like a valley of waves like this, where when viewed at one angle you see this, and another angle you see this. But if drawn in 3D, you could almost visualize the entire head shake all at once if you were able to see in those higher dimensions. And so that's pretty much all I have to show for this app. There's a few other interesting things, but I can't let this video go on forever, of course. But I do find it interesting more than anything. If this app kind of reveals to you what would you see if you could see in space-time. And one thing you would see is you would see a lot of shapes, a lot of motion and shapes that are parabolic in nature or even sine waves in nature. And so right now in real life, we don't actually see that frequently in life. We don't see sine waves, for example. We see a lot of linear motion. But if you were to view across time, and our world does unfold across time, we just can't see it. But if you could, you would see sine waves everywhere. So if you ask me, what does our world really look like to a creature in a higher dimension, I would say they're seeing a lot of sine waves. Any oscillating motion that we see is represented as a sine wave, and any other motion is represented very parabolically. And it's kind of fitting, and that's almost what you would expect to experience from a higher dimension. Because if we're plotting math functions and we have something like multiplication, that's where we kind of see these plots that are linear, which is what we're used to seeing in our 3D world. But if we were to go to a higher dimension, that is time, and look at our 3D world, and we were the same with math, if we were to go to a higher dimension, which is exponents, what do we get in math? Well, when we switch from products to exponents, we start to get parabolas, and if your base is negative, for example, -1 raised to the n, you get a cosine wave. And of course, that's actually a 3D cosine wave because it goes across the imaginary, the complex plane. So that might look a little like what this full combination would look like. So I find it interesting. We view the world kind of in this second order nature when it really exists in this third order nature. There's sine waves all around us more than anything else, but we just can't see it because of our limited scope. So that's my favorite thing about this app, is it kind of opens our eyes up to what motion really looks like across the time dimension. So if you don't have it already, I'm assuming you might be watching this video from the app. But if you don't, go on and head over to the Apple Appstore, search Spacetime Camera, and check it out. It's a lot of fun. I think you'll enjoy it. Thanks for watching.